521, logarithms. And you might be thinking, well, we already covered these. Well, that was just an intro. So now we're going to go a little deeper. Here we go. Got some not so easy ones. Got some really easy ones. So, what is this? Well, remember, base, exponent, answer. So 2 to the x equals 8. Yes, you could just use common sense and say x is 3. But common bases, happy places, I'm going to stick with that theme. And now x is 3, because these bases, once you get them common, they disappear, and the exponents have to be equal. Or this one, just weird looking. Don't panic, stick with the rules. Base, exponent, answer. And that just falls right into your lap. X is 5. Not so easy ones. A little more complex, but don't panic. No matter how hard they make it look, the rules are the same, and that's the key. Don't overthink these. So here's my base. My exponent's missing. So the square root of a to the x power equals that, which I'm just going to write as a to the 2/3. Now, you got to do some thinking here. What is the square root of 49? Well, there's a 1 there and there's a 2 there. So it's the same thing as 49 to the 1/2 power. I don't know if you know that, but I'm going to get rid of that x for a minute so we can concentrate on here. Here's a 1, here's a 2. So it's a to the 1/2 power, and there's an x there. And when you raise a power to a power, you multiply, so a to the 1/2 x equals a to the 2/3. These go bye-bye, so this exponent, 1/2 x, has to equal that exponent, 2/3. So I'm going to multiply by 2, multiply by 2, x is 4/3. So, a little more work there. Give myself some room for the next one. Stick with the program. Base, exponent, answer. This one's actually easier. 9 to the x equals, well, when you square a square root, you just get 3. So, I have a 1 here. I'm going to take that 9, get common bases, 3 squared. Now I have a power to a power, so it's 3 to the 2x equals 3 to the first power. Bases go bye-bye. 2x equals 1. I'll do it here. Divide by 2. X is 1/2. So there's that. Last one for this one. This is different. This is my base. This is my exponent. The first thing I'm going to do is rewrite it as a logarithm. 3x, that's my exponent, so base power log 3/27. And now watch this. This is different, but doesn't this spot have to equal that spot? So I just go, aha, x is 27. Let me pause this a second. Okay, on the board you can see I've got written slightly different. What I could have written was slightly more difficult than the not so easy ones. So this is really going to push you. So let's start here. Remember what I said, if there's nothing here, it's an implied 10. That makes this slightly different. So we go from here to here. 10 to the x equals -4. Now think about this. If I raise 10 to the first power, can I get a negative? If I raise 10 to a negative power, does that make it negative? No. This is just 1 over 10 squared. It's still positive. What I'm saying is, you can't raise 10 to a power and get a negative answer. So this is no solution. What the heck is up with this one? Well, maybe this is the first time you've seen this, but we introduce you to the letter E. Now this is called a natural log. Why didn't they make it NL, following natural log? Because if you flipped it, a lot of times students get that messed up. They think that's a 1. So that's why they flipped it, but that stands for natural log, which tells you the base is e. Very similar to this one, where there was no base, it was a 10. When you see the natural log, they're not going to put that there very often. You just need to know that it's an e. What's e? 2.71. Follow the program. E squared equals, that's all in my answer, 2/3 x plus 6. I know it's weird looking, but we're solving for x. So we get e squared minus 6. No, you do not need to go in your calculator, 2.71, square it. You could, but that's not what they really want from us right now. 2/3 x. So I'm going to multiply that side by 3/2. I'm going to multiply this side by 3/2. This side is just x. This right here is 3e squared over 2. And then when I hit that with 3/2, it's 18 over 2, which is minus 9. Yes, very fancy looking answer, but you just followed the rules of algebra and logarithms. Mr. Nasty, don't panic. Base, exponent. So it's 2 to the x to the 3x equals whatever's in my answer spot. Well, I got a power to a power situation there, so I multiply 3x squared equals 256. Now, 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32, 64, 128, 256. So right there, I got 1, 2, 3, 4, 5, 6, 7, 8 of them. What am I doing? Sticking with the common bases, happy places theme. So now the bases disappear, and I get 3x squared equals 8. And I'm going to divide by 3, divide by 3. I need some space for this problem. So I get x squared equals 8/3. This is where we go bada boom, bada bing, do the right thing. Don't forget that, because there's always 2 answers when you have to do this. This turns into 2 square root of 2. So I get plus or minus 2 square root of 2 all over the square root of 3. And you can't leave a square root down there. So we multiply. These two make the square root of 6. So plus or minus 2 square root of 6 all over 3. And you can't reduce this. So you're done. There's more coming. And now we're going to go one step deeper. I'm going to call these abstract because we're really not finding anything. Like all the previous problems, you're actually finding a solution. Now you're just moving stuff around properly. So the goal here, if they give you a logarithmic equation, you're supposed to write it as an exponential. If it's an exponential, you're supposed to change it to a logarithm. This one is an exponential equation. So, check it out. If I rewrote it, or just knowing that this is my base, I'm going to go log base 12. This is my answer, y. This is my exponent, so that would be there. This says 12 to the x power equals y. Same thing. Done. You're not finding anything. That's why it's abstract. What about this one? Well, this is my base. That means it's a natural log, e. This is my exponent, this is my answer. So my answer spot gets tucked in there. My exponent's always to the far right. So this says e to the x power equals y. We turned it into a logarithm. Now it needed to be a natural log because our base is e. So you have to just know that. So this one. This is a logarithmic equation. So now you're going to turn it into an exponential equation. Base, exponent, answer. 2/3 to the q power equals m. Done. How about this one? Well, this one's a little different, but there's an invisible e there, and if you need to turn it around so your brain can follow it the way I've been teaching it. Or if your brain works backwards, you can go here, here. I actually like turning these around. I'm more of a linear guy, kind of do the same thing every time. So I go e to the L, base, exponent equals my answer. Just put stuff where it belongs. That's what that is all about. All right, so we've been dealing with exponential functions. Here's your basic of all basics. This is the one where it applies more to like investing, population. And as you can see, a rabbit population doubles. So what that means is if we're using this, that's a 2. But if we're using this, that means the rate is 100% increase, which if we change that to a number, we move the decimal 2 places, it's 1. So 1 plus 1, that's where we get our 2 from. It doubles. Now what does it say? It says every year. So we keep that as t. Our initial population is 200. And that'd be the same thing here. As you can see, we're getting the same information. They're the same formulas, but this is a little bit clearer. But I gravitate towards these. If it's a doubling problem, I put a 2 there. If it's a half-life problem, I put a half in there. So, with that being said, I'm going to use this one. It's 200 times 2, and it says after 5 years. So, I got to just crunch the numbers out. 2 to the 5th, 2 times 2 times 2 times 2 times 2, 4, 16, 32. So I get 200 times 32. Well, 100 times 32 is 320, so that'd be 640 after 5 years. Okay, that's how you're going to use that formula right there. So I caught myself in a mistake. It's not 640, 6,400. Silly multiplication error. Okay, with that being said, we're going to move on to problems that are pretty bizarre. Solve for A and B. This is an ACT/SAT special. So you can see that A is sitting by itself in both of these. So I'm going to divide this by B to the 6th. Divide this by B to the 6th. So I get 36 over B to the 6th equals A. If I divide that by B to the 9th, divide that by B to the 9th, I get A is 12 over B to the 9th. Well, if A equals both of these things, then these weird looking things equal each other. Now one thing that I could do is, just to get rid of these in the denominator, multiply by B to the 9th, multiply by B to the 9th. So these cancel. And over here, B to the 6th, B to the 9th turns into B cubed. So I get 36B cubed equals 12. So then I divide by 36, divide by 36, and I get B cubed equals 1/3. That's the same thing as 0.33. So I'm going to take the cubic root of this, and I'm going to take the cubic root of 0.33, which is just a strange problem to do. But 0.33 raised to the 1/3 power, okay, 0.33 raised to the 0.33 power, okay, let's see this. I keep screwing up these buttons. 0.33 raised to the 0.33 power is 0.69. So I get B equals 0.69. I got to find A. Easiest place to put it maybe is here. So I'm going to go 36 over 0.69 to the 6th power. So we just got to kind of keep working like this. So 0.69 raised to the 6th power is, so I get 36 over 0.107. So 36 divided by 0.107 is 336.4. So there's A. and there's b. That's just a wicked, weird problem. So that finishes our lesson, you guys. So good luck on your homework.